Okay. Welcome back to Advent of Code 2022, Problem 8. I've got a big old carafe of coffee here. So we're going to see if we can pound through some coffee while pounding through some problems. At least try to get through Problem 8 today and maybe learn some stuff. Cool. So, Problem 8 is Day 8, Treetop Treehouse. The expedition comes across a peculiar patch of tall trees, all planted carefully in a grid. The elves explain that a previous expedition planted these trees as a reforestation effort. Now they're curious if this would be a good location for a treehouse. Naturally. First, determine whether there's enough tree cover here to keep a treehouse hidden. To do this, you need to count the number of trees that are visible from outside the grid when looking directly along a row or a column. They launched a quadricopter to generate a map with the height of each tree. It's represented as a single digit. Value is its height. 0 is the shortest, 9 is the tallest. It's visible if all the other trees between it and the edge of the grid are shorter than it. Only consider trees in the same row or column. That is, don't look diagonally. All of the trees around the edge are always visible. There are no trees to block the view. In this example, that leaves the interior 9 trees, blah, blah, blah. With 16 trees visible on the edge and another 5 visible on the interior, a total of 21 trees are visible in this arrangement. Given the map, how many trees are visible from the from the outside? All right, seems pretty straightforward. But I've said that before. Let's see how we do. It's the wrong one. This one. You seeing the right thing? Yes. Okay. Input 08 txt. And paste this guy in here. Okay, cool. So, what do we want the approach to be? I think this is as with most of these, you can take a very, direct algorithm approach to this and try to come up with a clever algorithm that solves it quickly. And probably that's going to get you to the right answer faster, but from a computing perspective and maybe from a implementation perspective also. But I'm more interested in these from the point of view of, how do I structure a problem and how do I go about setting up solutions in a way that is scalable to other problems I would come upon across in real life. So I think in this case we want to do things in a kind of more maybe object-oriented way, where we want to be able to populate a big struct with let's say the forest struct, with all of the data from the input, and then ask it how many trees are visible, basically. And within that, it'll do the math. And roughly speaking, I anticipate that looking like, for each row and for each column, go all the way from the beginning until you hit a tree that's taller than the rest, stick that in a hash set somewhere, or stick its coordinates in a hash set somewhere, and go all the way from the right and do the same thing on rows and columns, and then count up the results. And I say a hash set because we don't want to count duplicates, so we don't want to accidentally count this twice because it's visible from the left of this column and from the top of from the left of this row and from the top of the column. So I think, roughly speaking, that's how this is going to go. And I want to be somewhat test-oriented here. So I do think a vector of strings is totally fine. But let's go ahead and write the test, and I'm going to use kind of an outside-in type testing methodology. So, this is what I've been doing. Forest computes tallest trees. And this will be something like let forest let's see here. Let example input be, we'll go ahead and grab our example input. Strings. And so we want to say something like let forest be forest new example input. Forest dot count tallest, and we can assert that this is whatever it was, 16 plus 5 or something. Yeah, 21. Okay, and so we can instantiate this. And it'll be a grid, and we'll need to be able to look things up in the grid. But we're also going to need to be able to do some subtler things. Let's see here. Forest gets tree. So we can take this guy again. And forest get, we can just say get, and if we say 0, 0, we expect to get back 3. If we say 4, 4, we expect to get back 0 in the bottom right hand corner. And let's do some randomish one, like it's going to be row by column. So the third row and the second column is going to be a 5. Seems reasonable. And we can go ahead within this same test. I think we can say assert equal forest.getRow 3. And that would be 3, 3, 5, 4, 9. And get column 1. And that would be 0, 5, 5, 3, 5. Reading the second column there. Okay. And then it shouldn't be tallest, it should be visible. Visible. And then, what, I guess the thing in the middle is like forest gets visible trees. And again, this will be something like this same thing. And then we'll say let visible. Let's just say assert equal forest.getVisible in row. 1. And that should be a vector of coordinates, or actually a hash map of coordinates probably. I guess there's a canonical ordering here, so I'll make it a vector. And visible in row 1 is going to be 1, 0, 1, 1, and 1, 4, because this is visible by virtue of being on the left. This is visible by virtue of being taller than the tree to its left. This is not visible. This is not visible from either side. This is visible by virtue of being on the right. And we'll do the same thing here. And we'll use the third column. And this one will be, so the third column, so this one will be 0, 3, 4, 3, just the outsides. Okay. And I have to free my cat. Cat sleeps under the bed in the room where I stream, and then I close the door, and she gets trapped. Okay, so already feeling pretty good about these tests. Like, obviously, I could write some more. But I think if these are passing, I'm going to feel pretty confident, so let's not doing overkill. And now that I've kind of used the test to design the interface, let's go ahead and input the test harnesses here. So we can get this example input again. And if I were really good, I would be putting these in, I put this into a function instead of duplicating it everywhere, but it can be kind of, sometimes it's better to have duplication in your tests. I'm not sure this is one of those times, but I don't think it matters that much. Okay, example input, insert solve problem 08A, example input, and the answer should be 21. And we can go ahead and do the same thing for B, although I guess we don't know what the answer is yet, so let's not do the same thing for B. And then in terms of actually solving the problem, we will take the input, we will say let forest be forest new input. I guess this should be from strings input. So let's actually change these to, does this work if I do this like this? Yeah, it doesn't. All right, we'll change it. We'll change it later. New input, and then we will forest.count visible. Freeze. Okay. So let's derive some stuff. We want debug. We want, maybe debug is the only thing we want for us to have. Forest, trees should be a vec. of usize. And we impl forest. We can say put function new, and this is the one we're gonna rename to from strings. So this should be a say vec of string returns a self, and now we should be able to rename this strings, and then here we'll just have a pub function new trees vec usize, and this will just be self trees. And then this will and I guess this can fail, so we should make it a result. And so now this becomes let trees be strings dot into iter dot map x dot cares dot into it. It's already an iterator dot map. T usize parse, or is it t dot parse? I think it's t dot parse. No. Usize parse. Let's forget this. I want it to be this. And then we have to map the error. But let's collect that. Let's collect this, and then we'll figure it out. And this will just be self new trees is what we'll return. Okay, so we map over all of these strings. We get its characters, those correspond to each of the trees, and then is it toString? What does toDigit do? Ooh, it returns an option. So like if I put in 10 here, toDigit returns an option of a U32. So as usize is what I would want, but I need to or else. Okay, or, and this is couldn't parse tree as digit, and that returns an error. kick out, not so much. Getting close though. We can say dot map t as usize. Okay. A vector of type usize cannot be built over a result. Sure, that is true. If I throw this at the end, though, it can. Okay, and then self dot true. This needs to be an okay. Doesn't like this. We should be able to say trees dot map. And then trees will be a result of vac usize string. Nice. Nice, nice, nice. Okay. Cool. So that should parse. And then we need a few functions. We need get which just gets a certain tree. So that's easy. That's just self trees. Get already a function. It's just ij. I don't even have to clone it because it's not, because usizes are copy. Get row. And this is just self dot trees. This one I do have to clone, or I could return a reference. I don't think it matters tremendously. Oh, also this has to be a vector. So let's just return the reference. I guess with symmetry, for symmetry with get row, I'll just return an actual thing. And get column. And this one's gonna be self dot trees dot map or iter dot map row row j dot. I don't have to clone it, do I? Because it's copy. Okay, and then get visible in row. So here's where the fun begins. So we need to go two ways. We need to go forward and backwards through it. And we need to return every time there's a tree that's taller than any tree that's come before it. So let's go ahead and have a little helper function, which is get visible from front, and this will just take a vec of usize. Trees usize. And we'll return, oh, and also these need to return their coordinates, not just like an element. And so for get visible from front, we'll just say let mute max tallest so far equals 0. Let mute to return equals back new. And for tree and trees, if tree is greater than tallest so far, then tallest so far equals tree, and to return dot push tree. Otherwise, we do nothing. We can't push the tree on though. We need to push the. Okay, so this one's going to need to be a vector of just regular usize because we don't know what the columns are. And we want to say dot iter dot enumerate so that we have access to the index. Return to return. Okay. Tallest so far equals has to be a real thing. Okay. So now get visible in row becomes self get visible in from front, self dot get row I, dot map, so each number we now need to, so it's the ith row, so we need to return in. And starting to think that maybe I do just want these to be hash sets already. I think I do. So that'll change in one of our tests, but that's fine. So this will be let from front be this. Let from back be the same thing, but it will be trees. It will be self.getRow. I guess we can pull this out first. Let row be this. Get visible from front of row. And then get visible from front row dot into iter dot reverse. Probably gonna need to clone that. And then return from front dot union from back. Okay. And this isn't imported yet. And visible from front needs to be dot into iter. And this needs to know its type. set usize. And this needs to get mapped. So now this is a hash set, and why don't we like this? We expected a hash set of, oh, we need to collect, I guess. Somewhere. Clone this. No. What's going on? Union returns. A union. But for some reason, hash set usize. Okay. Does not like this because it's trying to create a collection of references. Clone all of those. They're eminently clonable. Okay, this works. Okay, so that's get visible in row. And I'm realizing get visible from list. I'm realizing that we can make this a little bit nicer if we just say get visible from list. We do this stuff there. This is trees. That's a vector of usize. And then we just say self get visible from list self dot get row I. Because now we get rid of this line. Ooh, not quite. Not quite. We can get rid of this stuff and say that this goes away, this goes away, these become trees. Visible from front, we reverse it, we collect. This is now the wrong type. And what's the issue with this collect? Get visible from front. Oh, needs an into iter and into iter. Okay, because which seems like it didn't do very much, but now get visible in column just becomes a very simple function. Namely, the analogous thing to the above. Get visible from list, self.get column j, into iter, map n, and this becomes n comma j. All right. That should be doing pretty well. And so now we need to get visible in general, which can just be size usize and self.getVisible, I guess, for row. Yeah, just do get rows. Let visible in rows be self.getRows, dot into iter dot map, no. This can be 0 through self dot n rows into iter, and we map the row into self.getVisible in row r, I guess I, to be consistent. Dot collect and let visible in columns be the same thing, but the analogous thing, columns into iter map I, and this will be self.getVisible in column j. And then we just return visible in rows, union, visible in columns, and I assume we need to clone here. All right. And rows is just returns a usize and is just self.trees.length is the number of rows, and columns is usize self.trees 0.length should do it. We can assert that self.trees is greater dot length is greater than 0. let's actually do that in the constructors also. Trees.length is greater than 0. And let's assert that self.trees0.length is also greater than 0. It's not self, it's just trees. Okay. And last but not least, we need pub function count visible. And that will be self.get visible.length. All right. We're getting yelled at in a few places. Count visible trees. I believe that's implied. Sure, we unwrap. What else you got for me, compiler? Visible in column. This needs to be a J. Visible in rows. Does its type need to be known? Yeah. Hash sets. Usize. And same thing. Thing here. Hash set usize can't be built over elements. Yep, that is fair. We need to union them together. If I call flatten on this, what happens? Ha, it just works. It just works. Okay, hash set. You're pretty cool. It just works. I really do love Rust's iterators an awful lot. Okay. Tallest so far is usize, tree is an at usize, that's fine. It's copy, we can dereference it all we want. Count visible. I need to handle the error, which, oh, I need to unwrap the error. If you don't know, the question mark syntax in Rust just means if I get a result that might be an error and I'm in a function that returns a result that might be an error, then and the error type is the same, so results, so string is the error type, then the question mark just kicks it out of the function as an error. It's really convenient. But these are tests, they don't return anything, so I have to unwrap the error, and then it'll just panic. Okay, and these, it's unhappy with me because I decided to change my type here to a hash set. So let's just map those. Same story here. And these are okay. All right. Let's see how we did. Cargo tests, problem. Wait, can I say this? Values used after move. Yeah, I sort of suspected that. Okay, and we have a couple of failures here. So get visible in row 1. So this is row 1. So 2, 5, and so 1, 0, 1, 1, and 1, 4 still seem right to me. But we're saying 1, 2, 1, 0, and 1, 1. So 1, 0, and 1, 1 agree, but it's saying 1, 2, which I don't agree with. Okay. So one thing we forgot to handle is when we get visible from list and we reverse this, we then need to then reverse the resulting the length minus n. So its length is 5 minus 1. We need to we need let length equal trees dot length. We need to reverse the coordinates in the end. And what's the issue here? Get visible from front. Oh. Okay, so now they're identical, except that 1, 2 is being treated as a correct answer, which it should not be. It totally should be. It's visible from the right. It's visible from the right. I missed that. And if we look at column 3, 7 is visible, 9 is visible, nothing in the middle is visible. Okay. And then the other one, forest computes visible trees, is failing. Okay, so this one, though, should be getting the right answer, and it's not. So, let expected be some vector. And it's going to have the entire boundary in it, plus some of the ones in the middle. Which I don't tremendously feel like typing out. I guess it's fine though. So 5 of those. So we're going to have 20 minus 4 on the boundary. 16. 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. So these will be 1, 2, 3, 4. 0, 1, 2, 3, 4. And then it's going to be the same thing. So let's actually get rid of these. And we'll say all of these except these are going to be easier to just do it. So those are all the 0, 4s, and then there's going to be 1, 2, 3, 4 here. 4's already done though. 4, 4, and so this will be 1, 2, 3, and then there are going to be 2 more. Let's just add in some spacing. And these are 1, 1 is visible. Top middle 5. 1, 2 is visible. Left middle 5. 2, 1. And right middle 3. From the right. 2, 3. Yeah. Sort equal, forest, count, visible, or sorry, get visible, expected, and then we'll say extra visible, and extra expected, and then this will be forest.getVisible difference minus complement expected and expected dot complement forest.getVisible, something like that. Probably this. There's probably going to be cloning issues here. So let's say let visible be forest.getVisible, and then let's say visible.clone. Doesn't like complement. Rust hash set difference is called difference. Okay. Oh crap. This is a little annoying. Ooh, that was definitely annoying. Ooh. They're very different. I'm a little skeptical. One. Maybe 1-2. 2-1. Okay, looks like I did that right. Extra visible, huh? Gets visible trees. So wait, this passes? Does. Interesting. Let's pick a more interesting column. Like 2. And in 2, we would expect to get back 0, 2, 1, 2, 3, 2, and 4, 2. Passes. Really interesting. It says we have 2 extra visible. They are all, most of them are in the 4th column. Oh. This is wrong. There should be 1, 2, 3, 4, 4, 4. And extra visible is 3, 2. Wait, 3, 2 is visible. It's visible from the left. 2, 3 is not visible. No, 2, 3 is also visible. Hold, please. Oh, there are 5 visible in the interior. I missed one of those. Bottom row, the middle 5. Is visible. Yeah, so that's 3, 2. So missed that in my expectation. And then okay, then now there are just 2 extra expected. So 4, 4, and 0, 1 aren't getting counted. 4 and 4, we would expect every single one of them to be visible. This is the 4th column. So 0, 4, 1, 4, 2, 4, 3, 4, and 4, 4. style does. Only giving the endpoints. It's not giving the middles. Because we've not included the boundaries. Okay, that's fair. So let's do let boundary be self.get boundary coordinates, and we will say boundary dot union this and then pub function get boundary coordinates will be a hash set of usize and will just be what's the nicest way to do this? Let's say let left be self.get column 0. But does the column, we want the column coordinates. So we'll say 0 dot dot self dot and column and rows into iter map these are rows, so this will be I, comma 0. We'll say let right be 0 self and rows to iter map. We probably want to collect. This will be self.n columns -1. Let top bottom top be 0 through n columns. Map j 0j. And let bottom be this, except this needs to be self.n rows -1. Okay. And then we just return left dot union right dot union top dot union usize. So we can yank this and and now it doesn't like this because I need to map I don't really have to map each one of these. Did I not do this somewhere else? Boundary. Oh, it's the same problem here. This feels kludgy. Say that to owned. Just Google the best way to do this. Rest chain hash set operations. Hash set. Not really finding a super convenient way to write this. What if I do it the other way? What if I do it like this? And can I do this as set of usize can't be built as a .cloned. Okay, there we go. That works. .cloned, and I can do .union, top .cloned, and then I can do collect each time. Can I do this? No. Okay, .cloned.collect. Hash set. Still feels kludgy, but collect hash sets. Collect. Okay. And for this one, rather than mapping it, we can say boundary.union visible in rows .cloned .collect hash sets .union visible in columns. Don't do any mapping. Boundary union cloned collect union cloned. Okay. Okay, and so now this really isn't anything we wouldn't expect. And we're getting proper answers here. So the answer appears to be 1676. Let's find out if that's right. I don't know why my terminal's not pasting. 1676, we'll put in there. And let's see what we got. 1676. Boom. Continue to part 2. Better refill my coffee before then. Content with the amount of tree cover available, the elves just need to know the best spot to build their treehouse. They would like to be able to see a lot of trees. To measure the viewing distance from a given tree, look up, down, left, and right from that tree. Stop if you reach an edge or at the first tree that has the same height or taller than the tree under consideration. If that tree is right on the edge, at least one of its viewing distances will be 0. The elves don't care about distant trees taller than those found by the rules above. The proposed treehouse has large eaves to keep it dry, so they wouldn't be able to see higher than the treehouse anyway. In the example above, consider the middle 5 in the second row. Looking up, its view is not blocked. Looking left, its view is blocked immediately. Looking right, its view is not blocked. Looking down, its view is blocked eventually. Its scenic score is found by multiplying together its viewing distances. Okay. It's considered 0. They want to be able to see a lot of trees. Okay. However, you can do even better. Consider the tree of height 5 in the middle of the 4th row, and you can do better. Okay. Okay, consider each tree on your map. What is the highest scenic score possible for any tree? Okay. Cool. I like this question. So, a couple things. Let's get rid of this. Let's take our same example inputs. Whoops. And the solution to problem B is 8. Okay, so that's what we're shooting for. Okay, and this is nice because we kind of already have a way to come up with visible trees. Sort of. But we need to be able to do it from a certain perspective. So let's do that. And I guess we'll need a couple things. Let's do a test for gets scene score of tree. And here we'll take that same example, input. And we'll say assert equal forest.get scenic score of, and the two examples are 1, 2 has a scene score of 4, and 3, 2 has a scenic score of 8. Okay. And then we're going to want to say gets, what do they call it? Viewing distance. Viewing distance. And again, we'll just take this. And let's see here. Assert forest.get boundary coordinates dot into iter dot map ij forest dot get viewing distance ij is 0 dot all. That's not how dot all works. This needs to be all. And why is this? Okay, so the whole boundary should be 0. We can say forest.get viewing distance of but we need to give it a direction also. So that's not ideal. Let's just say let's just say 0 through forest.n rows. And this is all of the rows, so it'll be I, and we will go from I to 0. Direction. Put the direction up front. So the ith row 0. So let's say direction left, and that's 0. And we'll do the same thing. And columns J, whoops. And direction will be 4J, and that means we're at the bottom, so it should be down. And then we'll do some middle ones, like direction down, or let's go up. 1, 2 should be 1. And let's go right. Where's a really long way? 2, 0 should be 1, 2, 3, 4. See all the way to the edge. Okay. This seems pretty sane. So let's implement a couple of things. So first thing is we need a direction struct, actually enum. Let's derive everything for it except default. Direction. Left, right, down, up, and pull direction. And the main thing we want to be able to do here is get a thing that we can increment, I guess. Get delta, we'll call it. Pub function get delta, which will return a usize. That's like a vector. It can't be a usize. I32. That's like a vector that we can use. And this will just be match self. Self left, you get -1, 0. Self right, you get +1, 0. Down, you get -1. You get 0, -1. And up, you get 0, +1. Otherwise, I don't think we need very much from that. And then we will say pub function score, get scenic score, self I guess there's max scenic score also. That's fine. We can max it ourselves. I usize, j usize, and this returns a usize. And this will be self.trees.get ij dot map. Nope, doesn't need to map. Let's see here. It's just self.get visibility distance, something about distance. What's it called? Viewing distance. Viewing distance. Direction left I j times self.get viewing distance. Direction right ij, and so on. viewing distance, direction, I U size, J U size is a U size. And what to say here? Let me to return equals 0. Let mute coordinates equal, what's here? Let delta be direction dot get delta. Maybe I want to actually say let line segment or let view line be get view line. Yeah, it doesn't work. Maybe I just match. Let view line be match direction left. Then we want 0 through I minus 1. So we're gonna have to handle all the case where I is 0. So let's do that. If direction is direction left and I equals 0, nope, J equals 0. Return 0. If direction is direction right and J is self dot n columns, minus 1. Turn 0. If direction is direction down and I is 0, turn 0. And if direction is direction up and J is self.n rows, return 0. Okay, obviously that's a little redundant, but what are you gonna do? Okay, view line. So now this can never fail, and we can into iterate. And so those are all of the, this should be J minus 1. Yeah. Map J. Nah, do I want to call that J? It's map Y, map X. I comma y. Collect. Direction right. J plus 1 through self.n columns minus 1. Don't know if these need parentheses, but gonna do it anyway. Into iter map y iy collect. Direction down 0 through I minus 1 to iter map y no, map x j I plus 1 self dot n rows minus 1. Bunch of potential off by 1 errors here, and I'm probably falling into one of them, but that's what we have tests for. Okay. So those are the view lines. Those should be vectors. And then we get to just go through, we get to just count the length of the vector, right? So you know what I'm gonna do actually is say pub function get view line self direction I size j size a vector of u size. What did I do here? And then that's going to be this. And just return. And then view, we don't return 0 though, we return the empty vector. And, you know, while I'm here, it's fine. Return back new. Return back new. Return back new. And then this guy just becomes self.get view line. Direction ij dot length. Okay. Cool. And now we just implement our actual function, which is this force dot and I guess let's do it as force.max scenic score. And I guess we will go ahead and implement that. Pub function get max scenic score. And this will be self.trees into iter flatten flat map 0 through self.nRows into iter. Map 0 self.nColumns into iter dot map. Call this J. Call this I. And we say self.getScenic score ij. Dot collect. Dot flatten. So let's see how this works. So we go through all of the I's. Okay, so these are all the rows. We map that. We flatten, and then we dot max. And I think that can return an option as the problem. Yep. Expect at least one element should be in the forest. Okay. And now the only problem is it doesn't know what this collect is. Yep. And this can just be a back of whatever it wants it to be. Okay. And we need to get in here. Very good, very good, very good. And I think this should be in pretty good shape. Let's see what our tests say. Our tests say that our viewing distance function is not working. Get viewing distance. It is failing on so not all of our columns, not all the time when we look at 4, J, 4th row, Jth column. That should be this. Looking down, we're not always getting 0. So get viewing distance, get viewing line. So what we should have here is when the direction is down. Oh, this is wrong. When the direction is down and ooh, there are a couple things wrong here. These should be I's. But also when the direction is down, we're concerned with self.nRows -1. And when the direction is up, we're concerned with 0. Okay. Let's try that again. Okay, viewing distance. And now, okay. Now it's happy with me up until I try to ask about the viewing distance up from 1, 2. So 1, 2 is that one. And the viewing distance up, in my view, should be the length of the vector with a 3 in it, which would be 1. Believe that's correct. So So we'd get past all these, and then we would say up. Yeah, and okay, basically I have the same bug here. Whoops. Why is my... What is happening? My Vim is doing strange things. It says it's in normal mode. Oh, I have cap lock on. That's why. Okay. So the issue is essentially that these two are backwards. So this should be down, and this should be up. Yes, so now if you're looking down, you go through all of the rows below where you're at, and vice versa. Good stuff. And still failing. Okay. So now, though, it thinks that looking up, we get a 0. So direction up, 1, 2 is definitely this one. We're looking up. We're going to go from 0 to I minus 1. These are exclusive. So here's the off by 1 error we were talking about. Get rid of these minus 1s. This is why we have tests. Boom. Okay. So all those are passing, and now the scene score. So the scene score of 1, 2 is this one. And I said it was 4. So it's 0. Wait, shouldn't it be... Oh, at least. I think I'm not doing... Well, okay, 2 things. One is I don't understand why... Oh, I completely missed a feature of the problem, which is that the viewing distance is not just the full line, it's the line up until we hit a higher tree. And it's a strictly higher tree, yes, not a slightly higher tree. Stop if you reach an edge, or the... No, not a strictly higher tree. Same height or taller. Same height or taller. Looking left, it's blocked immediately. Oh, but it does see that one. Looking up, it sees 1. Okay. So this is going to be let trees to check be this, and then let me to return would be a new vector, and for tree and trees to check, we'll say let mute we don't care about that. Then we can say to return, or actually if self.get tree.0 tree.1 is greater than or equal to let's say greater than or equal to height to match. Then we say to return push tree return to return, and otherwise we just push it and keep going. So actually we can put this out here, yeah? Oh, there. Here. And then if we get all the way through the trees, we just push the whole thing. We return to return. Okay. And what are we unhappy about here? Type has to be known. Okay. And trees to check, probably same thing. Get scene score of tree, still failing for the same reason. Okay. So it's 1, 2. Still this one. We expect it to go left and say, okay, it's just the 1. We expect it to go up and say it's just the 1. We expect it to go to the right and say 2. And we expect it to go down and say 2. That sounded like 1 times 1 times 2 times 2, which is indeed 4. Hang on, 1, 2. 1, 1, 2, 2. Yeah, that should be 4. But scenic score is not 4. Let's just drill into it. Seems like the easiest thing. So going left. We need to comment these out for the moment. Okay, so we get through all of these successfully. We're going up. And going up, the trees to check has length 1, which sounds correct to me. And I can't remember. Okay, so going up, it should say it's fine. And then it should return. I just commented out the wrong one. That's not the failing test. The failing test is this one. Okay, going left. I have to check 2 trees. I don't match the heights. I do match the heights. So I say 2. Is that right? No, going left, I should match the height the first time. I matched the height the first time. Okay, we're going left. Height to match is 5. I'm checking 1, 2. I shouldn't be checking 1, 2. I am 1, 2. Oh no, I'm not checking 1, 2. I'm checking 1, 0. Shouldn't I be checking 1, 1? Ooh, got it. Okay, a couple of these need to be reversed. So if I'm going left, then I need to reverse this. And if I'm going up, then I need to reverse this. Because otherwise, I'll go 0, 1. I'll count from the left, but I want to count from the right. Only one failed. That's a good sign. And it failed with a big number, which is also a good sign. And it failed with a number that looks like a product of 4 smaller numbers, which is also a good sign. Okay, so it means that we passed the main test. So let's see if this is correct. 313200. 313200. 13200. Submit. Boom. Day 8. Done in 2 hours. Right on time. Sick. We've gotten to some kind of different colored thing in our little roguelike-y text diagram here, which is exciting. Awesome. I'm going to wrap up there. Let's just add this so that it's on the GitHub. Ooh, let's cargo test just to see all it pass. Why didn't it pass? There we go. Okay, that's it passing. Solve problem 8, and we'll push that in. Awesome. I'm gonna wrap up here for the day. I will be back maybe tomorrow, depending on whether it's nice outside and whether I want to do something outside. If not, I will be back on, oh no, tomorrow's Tuesday. I will definitely be back tomorrow afternoon at 1 p.m. EST to do problem 9. Hope everybody's having a good Monday. If you haven't already, please follow. And yeah, have a good one. I'll catch you guys tomorrow.